Imagine tearing open a warm bag and hearing that first satisfying crackle. That tiny, gloriously loud sound that promises salt, crunch, and instant comfort. Whether you reach for a neon orange nacho cheese chip, a classic salted triangle, or a pillow-light cheese puff, snacks are more than convenience food. They're small celebrations of texture, flavor, and industrial craft. But behind every crunch is a surprising mix of ancient techniques, high-tech machines, and modern chemistry. Today we're pulling back the foil to reveal how tortilla chips and cheese puffs are really made, why scientists and regulators sometimes worry about things like acrylamide, and what to watch for if you want the same great taste with fewer surprises. The story of tortilla chips reads like a food industry fairy tale. Humble origins, a clever reuse of leftovers, and an explosion into a multi-billion-dollar snack market. Legend says tortilla chips were born when a Los Angeles tortilla maker, often named in stories as Rebecca Webb, decided to fry up scraps from tortilla production instead of throwing them away. What started as kitchen thrift turned into a sensation, and brands from regional favorites to global giants scaled that idea into the packaged chips we shove into party bowls today. But the journey from field to chip is a fascinating blend of pre-Hispanic tradition and modern mass production. It all begins with corn, the plant that built civilizations across the Americas. For tortilla chips, corn doesn't just get ground, it goes through nixtamalization, an age-old process the Aztecs and Maya refined. Whole dried kernels are soaked and simmered in an alkaline solution, traditionally lime, calcium hydroxide, at controlled temperatures for many hours. That alkaline bath loosens the hulls, improves the dough's texture, and most importantly unlocks niacin, vitamin B3, and other nutrients, turning otherwise harder-to-digest kernels into a soft, flavorful masa. After the soak, the kernels are rinsed and passed through heavy mills, often with counter-rotating stone or steel rollers, to grind them into a moist, pliable dough called masa, typically carrying around half its weight in water at this stage. From masa to chip, modern factories move with machine-like choreography. Masa is rolled into uniform sheets, usually 1 to 2 millimeters thick, then stamped by a high-speed cutter that forms triangles, circles, or other shapes. Trimmings aren't wasted. Scraps get remixed and recycled into the next batch, maximizing yield. The cut pieces enter a pre-bake oven, a short, intense heat that dries the surface and stabilizes the shape so chips don't collapse in the fryer. After a quick bake, often mere seconds at elevated temperatures, the semi-finished pieces hit the fryer, where oil temperatures typically range between 350 to 375 degrees Fahrenheit, about 175 to 190 degrees Celsius. That flash frying step drives out remaining moisture in an explosive puff of steam, creating the porous, airy texture we love and imparting a toasty, golden color as the Maillard reaction develops the savory notes. Not every manufacturer fries. Some brands use hot air baking or specialized industrial ovens to produce lower-fat chips that still aim for crunch. Whether by fryer or oven, the goal remains the same. Remove just enough moisture to render a crisp, shelf-stable product without burning, while keeping surface oil at levels that help flavors cling. Once crisp, chips tumble into seasoning drums where a light oil mist, sometimes just a whisper of vegetable oil, is sprayed on to act as an adhesive. Then powdered seasonings, salt, cheese powder, chili, garlic, onion, and other natural or artificial flavorings, are dusted on and tumblers ensure even coverage. Automated vision systems and metal detectors then screen the line. Burnt, undercooked, or misshapen pieces are rejected before the chips are weighed, nitrogen flushed to displace oxygen, and sealed to lock in crunch and aroma. If you've ever tasted the first lick of a freshly opened bag of cheese puffs, you know how intoxicating that toasted cheese aroma can be. The origin of cheese puffs, like many great snack inventions, is often described as a happy accident. A feed mill extruder left its compressed cornmeal residue and out popped puffed bits that, when baked and dusted with cheese powder, turned into an instant hit. Today's process is more controlled but follows that same physics. Whole corn kernels are cleaned, dried to the right moisture, often 12–13%, and ground into fine cornmeal. That meal mixes with water and small amounts of oil and is forced through an extruder. 2 counter-rotating screws knead, compress, and heat the dough by friction. When the hot, high-pressure dough exits through a die into normal atmospheric pressure, the sudden drop causes the water to flash into steam, puffing the dough into airy strands. Those strands are immediately cut by a high-speed knife into bite-sized pieces and transported through a dryer where staged heating zones gently remove residual moisture without charring the puffs. The result? Snacks that are crunchy on the outside, tender inside, and surprisingly light. From dryer to flavor drum, the process mirrors chips. A fine mist of oil helps cheese powder, salt, and spice blends cling to the surface. Blending drums ensure uniform coverage, and rapid cooling stabilizes the product's structure so bags don't implode or go stale. Packaging lines weigh each bag, pump an inert gas like nitrogen, seal and date stamp, and bundle for palletizing. The choreography is fast. A modern snack line can turn out thousands of pounds an hour, but every bag is the product of dozens of calibrated steps. Let's talk about the chemistry that makes those golden colors and toasty flavors, and the reason regulators sometimes raise red flags. When starchy foods are cooked at high temperatures, they undergo Maillard browning. Sugars and amino acids react to produce complex flavors and brown pigments. Unfortunately, under certain conditions, notably high heat and lower moisture, another compound can form, acrylamide. Acrylamide develops primarily in starchy, carbohydrate-rich foods cooked at high temperatures, such as fried or baked potato products, some breads and yes, tortilla chips. Studies in animals have shown that high doses of acrylamide can increase cancer risk, and because of that, public health bodies recommend reducing unnecessary exposure where feasible. In people, evidence is more mixed and research continues, but regulators like the FDA have advised manufacturers to monitor and minimize acrylamide levels when possible. So what does that mean for you as a snack lover? First, moderation works. Occasional indulgence in chips or puffs as part of a varied diet is different from consuming them several times a day. Second, product choice matters. Some manufacturers adjust frying temperatures, use shorter fry times, or favor hot air baking to reduce acrylamide formation and total fat. Lighter-colored chips generally contain less acrylamide than deeply browned ones, so avoiding over-toasted snacks and choosing brands that advertise lower temperature processing or baked options can help. Storage and reheating tips matter less than cooking methods, because acrylamide forms during the original high-heat processing, not in your pantry. Finally, industry-wide, many snack makers follow voluntary guidance to reduce acrylamide through recipe tweaks, processing controls, and careful raw material selection. If you care about acrylamide, look for brands that publish their food safety measures or choose baked, air-popped, or lower-heat processed snacks. Beyond acrylamide, there are other everyday concerns. Salt, calories, and the role of fats. Frying adds oil by design, and that contributes to calories and mouthfeel. That oil can be a blend of vegetable sources and sometimes contains saturated fats depending on the formulation. Some brands use high oleic oils for stability and a longer shelf life. Seasoning powders can include artificial flavors, monosodium glutamate, MSG, in small amounts for umami or natural ingredients. If your concern is sodium or added ingredients, the easiest choices are baked chips, lightly salted labels, or snacks made with simple ingredient lists, corn oil, salt, and perhaps an added seasoning of natural spices. Back at the farm, the story starts long before any factory. In Midwestern corn country, harvesters pull ears from fields of variants like dent corn, bred for feed and industrial use, to processing complexes where kernels are mechanically stripped from cobs by high-speed shellers. The raw kernels are cleaned by air and screens to remove husk, silk, stones, and foreign material, then dried to ideal moisture for storage and milling. Temperature-controlled silos preserve quality until the kernels are nixtamalized or milled into flour. For extruded snacks, moisture control is crucial. Too wet and the dough won't puff, too dry and it will crack or yield dense snacks. Even small variations in kernel quality change texture and yield, which is why factories invest in precise sampling, moisture meters, and quality control labs that test protein, starch, and oil content. Quality control is everywhere in the plant. Technicians take line samples to check moisture, color, texture, and flavor. Metal detectors, X-ray scanners, and vision systems catch contaminants and physical defects. Shelf stability tests ensure that the product remains crisp for the duration of its stated best-by date. Food safety teams monitor for microbiological hazards, and packaging engineers design multi-layer films that block light and oxygen to prevent staleness. In many modern facilities, sustainability enters the conversation too. Manufacturers optimize frying oil turnover, invest in energy-efficient ovens, and source ingredients with traceability for responsible sourcing claims. There's artistry and science in the flavor houses too. Most iconic flavors, nacho cheese, Cool Ranch, lime chili, spicy jalapeno, start as prototypes in R&D kitchens where chefs and food scientists balance taste, mouthfeel, aroma, and powder adhesion. Natural cheese powders are made from dehydrated dairy. Artificial flavors use aroma compounds to mimic complex savory notes at lower cost. Texture engineers consider particle size, density, and even how a powder dissolves on the tongue. The result is a formula that can be scaled from a lab shaker to a 1,000-gallon seasoning blender without losing the oomph you expect. For consumers who want the taste without the guilt, there are practical moves. Try oven-baked or air-popped alternatives. Look for words like baked, not fried, air-baked, or reduced fat on labels. Choose lower sodium varieties or portion your snacks into bowls rather than eating from the bag. Small behavioral nudges that cut intake without sacrificing joy. If acrylamide concerns you, favor lighter-colored chips and products from brands that promote reduced acrylamide processing. For the home cook, making tortilla chips is simple and much lower risk. Cut corn or flour tortillas into wedges, brush lightly with oil, bake at moderate heat until just crisp and golden, avoid charring, and season to taste. That way you control oil, salt, and browning. Have you ever reached into a bag of your favorite snack, pulled out a golden puff, and wondered how something so airy, crunchy, and perfectly flavored can stay that way for months on a shelf? Behind every bite of those cheesy puffs, twisted pretzels, or sizzling strips of bacon lies a story of food science, industrial engineering, and centuries of culinary tradition blending into modern American culture. We don't usually think about it when we're snacking in front of the TV or grabbing a quick bite during a busy day, but the journey from raw ingredient to packaged perfection is one of the most fascinating, and sometimes surprising, processes in the food world. Today we're going behind the factory doors to see how some of America's most iconic snacks are made: cheese puffs that melt in your mouth, pretzels with their signature glossy crust, and bacon, the smoky, salty indulgence that continues to dominate American breakfast despite controversy. What we uncover will forever change the way you look at your snacks. Cheese puffs might seem like the most harmless guilty pleasure. They're light, airy, and so addictive you can polish off half a bag without even realizing it. Americans consume over 6 billion bags of cheese puffs every year, according to the Snack Food Association in 2023. Think about that for a second. That's billions of little crunchy bites disappearing in living rooms, classrooms, and office break rooms across the country. But keeping those puffs crisp and cheesy for months at a time isn't a happy accident. It's a carefully controlled process of extrusion, cooking, dehydration, and flavor science. Each puff begins as cornmeal mixed with water, pressurized, and blasted through a high-temperature extruder where the sudden release of steam causes it to puff instantly, like popcorn. The golden pillows are then coated in a fine mist of cheese powder, salt, and flavor enhancers that give them that unmistakable tang. But even more impressive is how they stay crunchy. The bags are sealed with nitrogen, not just air, to prevent staleness. So when you hold that bag in your hands and tear it open, the puffs inside taste almost exactly like they did when they rolled out of the factory. Now let's shift to another favorite: pretzels. At first glance, pretzels might seem simple, just twisted baked dough sprinkled with salt. But they hide a secret that even many snack lovers don't know. To achieve their signature glossy brown crust, pretzels undergo a chemical dipping step that uses a strong alkaline solution, sodium hydroxide, also known as lye. This is the same caustic compound that can corrode skin if mishandled, yet it's an essential part of pretzel making. Don't worry, the heat of the oven neutralizes it, transforming it into a safe food compound, sodium carbonate. Without it, pretzels would look pale and taste like soft breadsticks. This chemical bath is the hidden magic behind their satisfying crunch and deep, savory flavor. Pretzels are far from a modern invention. Historians trace them back to the 7th century, when European monks twisted strips of dough to resemble folded arms in prayer. They were given as rewards to children who memorized their prayers, and from there, pretzels became associated with luck and prosperity. By the time German immigrants brought them to America, pretzels had become a cultural staple. Pennsylvania, where these immigrants settled in large numbers, is still considered the pretzel capital of the United States. From that humble beginning, pretzels have grown into a billion-dollar industry. Today, massive Pennsylvania factories churn out millions of pretzels daily, feeding both local traditions and global markets. Inside one of these factories, the process begins with silos of flour pumping directly into industrial mixers. Warm water, yeast, and salt are added with precision down to the kilogram. Dough hydration must hover around 60%, just moist enough to twist without cracking, but firm enough to hold shape during baking. If the formula is even slightly off, the batch can be ruined. After mixing, the heavy dough rests in proofing chambers kept at 86 degrees Fahrenheit with controlled humidity. Yeast activates, creating tiny bubbles that give the dough its soft interior. From there, lightning-fast robots cut and twist the dough strips into the familiar pretzel shape, completing each twist in less than 2 seconds. Any misshaped pieces are detected by cameras and whisked off the line. Then comes the alkaline bath, a quick 3 to 5 second dip in sodium hydroxide solution before heading straight into blazing oven set above 425 degrees Fahrenheit. After 8 to 10 minutes, the pretzels emerge with their glossy brown sheen, showered with coarse salt and cooled with cold air. Packaging machines bag them in moisture-resistant plastic, flush them with nitrogen to lock in freshness, and seal them for a shelf life of up to 9 months. The next time you bite into a pretzel at a ballgame or pull a bag off the grocery shelf, you're tasting a centuries-old tradition perfected by modern chemistry and machinery. But if pretzels are a story of chemistry and culture, bacon is a story of controversy and obsession. Few foods spark as much debate as bacon. It's smoky, salty, and undeniably delicious, yet it's also classified by the World Health Organization as a Group 1 carcinogen, the same category as tobacco and asbestos. Just 2 slices a day, according to a 2015 report, can increase the risk of colon cancer by 18%. And still, in 2023, Americans consumed over 6 billion pounds of bacon, according to the USDA. Clearly, bacon's cultural hold on the U.S. runs deeper than health warnings. Bacon's story stretches back to ancient Rome, when pork belly was salted and smoked to last through long winters. European settlers brought the tradition to America, where it became a staple of farm breakfasts, providing much-needed calories for physically demanding days. Over time, bacon transformed from a simple farmhouse food into an American icon. Fast food chains wrapped it around burgers, chefs sprinkled it into desserts, and social media celebrated bacon everything from donuts to vodka. But modern bacon is a far cry from the slabs smoked over wood fires in the past. Today it's an industrial product crafted in highly controlled factories, where consistency and speed are everything. It all begins with pork bellies arriving at massive processing plants. Workers inspect each slab, grading them for fat-to-meat ratio. USDA standards require about 50 to 60% fat for commercial bacon, ensuring that perfect balance between crispy edges and juicy flavor. The bellies are then moved into injection machines, where hundreds of fine needles pump them full of a curing solution containing water, salt, sugar, sodium nitrite, and phosphates. This solution makes up about 10 to 15% of the meat's weight and ensures even curing. Sodium nitrite plays a crucial role in preserving the meat's pink color and preventing bacterial growth, but it's also controversial because it can form nitrosamines when cooked at high heat, compounds linked to cancer risk. Producers now use various methods to limit nitrosamine formation, such as antioxidants in the cure, but the debate continues. Once cured, the pork bellies rest in cold rooms for up to a day, absorbing the flavors. Then comes the smoking stage, but in modern plants this usually means liquid smoke. Instead of hours in a smokehouse, the meat is sprayed with smoke essence in sealed chambers, picking up aroma and color in just a couple of hours. To the consumer's nose and palate, it smells like real smoke, but in reality, it's a highly engineered shortcut. Next, the slabs head to heat chambers where they're cooked to precise USDA standards, between 143 and 149 degrees Fahrenheit to kill pathogens while preserving texture. Immediately after, they're blasted with freezing air at below 24 degrees Fahrenheit, locking in the structure before slicing. The slicing stage is almost mesmerizing. High-speed blades cut the bellies into strips just a couple millimeters thick at a rate of up to 500 slices per minute. Workers barely touch the product. Everything is automated, from slicing to stacking to vacuum sealing. Some packages are flushed with nitrogen gas for longer shelf life. The whole journey, from raw pork belly to packaged bacon, now takes less than 48 hours. What once took weeks of slow curing and smoking is compressed into 2 days by technology. And yet, for all the warnings and industrial shortcuts, America's love affair with bacon shows no signs of fading. It's part of our culture, tied to breakfasts, burgers, and even indulgent food trends. It's controversial, yes, but also irresistible. Much like pretzels and cheese puffs, bacon is proof that the foods we take for granted every day carry incredible stories hidden behind their flavors. When you sit down with a bag of cheese puffs, a salty pretzel, or a sizzling strip of bacon, you're not just enjoying a snack. You're tasting centuries of tradition, billions of dollars in engineering, and some of the most fascinating food science on the planet. Every crunch, every bite, is the product of precision, history, and a little industrial magic.